So we're looking at algebraic expressions, and when you just hear of algebraic expressions, that's to do with you getting to simplify letters and operations with numbers. Now, one thing you need to understand when you're dealing with algebraic expressions is board mass, right? This is very, very important every time you're dealing with algebraic expressions. So let's say you've been given something like x multiplied by y plus 2z minus 4. Let's say you have got uh, z plus 2y, and then let's say x there. They've asked you to simplify this thing. For you to do that, you need to first remove the bracket. So that's brackets off from the board mass. I'm going to multiply x with what is inside. So what you are going to have is xy, and then x times 2z, that is going to be 2xz, right? And then you are going to get this negative 4 and this x. So that is what? Negative 4x. So negative 4, this negative 4 times this x. So this x which is outside, I can also write it here. It's the same thing, alright? So we're going to have negative 4 times x, that's negative 4x. So that negative 4x we're going to multiply by z. So we're going to have negative 4xz. And then the same negative 4 times x, which is a negative 4x, multiply also with a 2y, right? So that is going to be negative 8xy. Is that okay? Is that okay? Are we moving together?
Yeah, quotation plus quotation plus one. So times six, so six, so four times two, eight, eight nine. So yeah, six, so times eight, something like that.
So you just multiply this 4 with z and then also with x. This x and the 4, they are both outside the brackets, meaning that they are together. Okay, so it is just the same as 4x. So you get this 4x, you multiply by z, and then you get the same 4x, you multiply by 2y. That is what we are doing. Okay, is that okay? So from here now add like 10. So I've got xy negative 8xy. So 8y minus, xy minus 8xy, that is going to give you negative 7xy. And then 2xz minus 4xz, this will give you negative 2xz. So if I want, I can factorize out x, but you can as well end here. So this is how you get to simplify these terms. Make sure that you just look at what is common, right? We can look at these other examples on algebraic expressions. Simplify 6x squared minus 24 divided by x minus 2. Now, when you see expressions like this, you need to make sure that you find the difference of two squares, okay? So first on top, I'm going to factorize out 6. So we're going to have 6, open brackets, x squared minus, if I remove 6 from 24, I'm going to remain with a 4. And then divided by x minus 2. This will give us 6 x squared. I'm also going to write 4 as a square. So 4 is the same as 2 squared. Then down we have got x minus 2, right? So this thing here is the difference of 2 squares. So we can as well write this as 6. X squared minus 2 squared can be written as x minus 2, x plus 2. That's a difference of 2 squares. And then down we have got x minus 2. So this x minus 2 and this x minus 2, they'll cancel out. We're going to remain with 6, open brackets, x plus 2. Is that okay?
Yes, it's okay.
Right. We can consider also this one. Simplify 25 p to the power 4 divided by 7 q squared divided by 5 p to the power 6 over 21 q to the power 4 times 5 p over 15q. So again, what you need to do using the board mass, I'm going to change this division into multiplication. So we're going to have 25 p to the power 4 over 7q squared, and then becomes times. So what was down goes on top, 21 q to the power 4 over 5 p to the power 6, and then times we're going to have p divided by 15q. And then from here we'll start dividing, all right? So 5 will cancel with this, so we're going to remain with 5 into 25 will give us 5, right? Then this 5 again will cancel into 15, so we're going to remain with a 3. And then 7 can go into 21, that is the 3, right? So again, this 3 will cancel with this 3, you see? And then this p can cancel with one p down here. So one, sorry, that's not a p. So this p which is here will cancel with one p here. So we're going to remain with the 5 p's, all right? And then 4 p's will cancel with the 4 p's here. So we're going to remain with only one p. And then these two q's will cancel with two q's here. We're only going to remain with the two q's. And then 1q which is here will cancel with 1q here, so we're just going to remain with 1q. So on top everything is cancelled, we are only remaining with a q. And then down also everything is cancelled, we are only remaining with a p. So this is going to be the answer, q over p. Is this okay?
Yes.
Right. Simplify a minus 12 divided by a squared minus 144. Same, this where there is a square, we need to express it as the difference of two squares. So I have a minus 12 divided by a squared minus 144. Also going to write it as a square. 144 is the same as 12 squared. So this is going to be a minus 12 divided by a squared minus 12 squared can be written as a minus 12 and then a plus 12. So a minus 12 will cancel with a minus 12. So on top we're just going to remain with a 1. Down we have remained with a plus 12. So this is going to be the simplified form. So we have simplified. We can also consider this one. Simplify 39x to the power 3 divided by 28y to the power 4 and then divided by 65x to the power 5 over 56 y to the power 6. So again, what are we going to do? We'll change into multiplication. So this is 39x to the power 3 over 28 y to the power 4 times, we're going to have 56 y to the power 6 over, we have 56, sorry, that is 65 x to the power 5. So what was on top comes down. Now here again what we're going to see is x to the power 3 will cancel with x to the power 5. So what will remain is just x power 2. Okay, you have got 5 x's here. The 3 of them are going to cancel with these 3, so only remain with 2. And then y power 4 will also cancel with y power 6, so you only remain with y power 2 there, right? And then you also look for a number that can go into 39 and into 65 without leaving a remainder. So basically what we are doing is that this 39 here, this 65, look for a number that can go into those two without leaving any remainder. So that is what we are doing. So any number that you can think of that can go into both without a remainder, we can start by a 3. Okay, we can start by a 3. 3 into 39. We know 3 can go into 3, that is 1, right? And then 3 can go into 9, that is how many times? 3 times, isn't it? So that will give us 13. And then we also go into 3 into 65. So 3 into 6 can go there how many times? So we are saying that 3 cannot go into 65. Okay, 3 cannot go into 65, meaning that we are not going to use the 3. So again, look for another number that can go into these two without leaving a remainder. So let me also write this as 39 over 28 times 56. Remember, we have got y squared which has remained over 65. We have got x squared which has remained, so that we can now work with it properly. Okay, so since 2 can't go here and 2 can't go here, we know 3 also can't go into both of them, right? We are looking for a number that can go into both of them. What of 5? 5 can't go into both of them. What of 6? 6 can't go into both of them. What of 7? It also can't go into both of them. 8 can't go into both of them. 9 can't go into both of them. 10 also can't. 11 also can't. 12 also can't. 13. Okay, we can try 13 if it can go into both of them. Okay. Can 13 go into 65? That is also something that we should be able to find out. 13 can go into 65, yes. Okay. So that is the simplest number that can go into both. So 13 into 39 is going to give you 3. 13 into 65 is going to give you 5. And then also look for a number that can go into 56. This number on top, and also into 28 without leaving any remainder. Do you know of any number that can go into both of them? Okay, we can look at 14. Okay, 28. 14 can go into 28 2 times. What of into 56? How many times can 14 go there? So 14 will go into 56 4 times. Okay, like that. So I mean that 56 can be divided by 14, and then 28 can also be divided by 14. Is this okay? All right. So again, you can see that 2 can go into what? Into 4. 2 times. So what we are going to remain with is we have remained with a 3 here. Down we've remained with only a 1 because everything cancelled. And then the other side we have remained with a 2y squared on top. Down we've remained with a 5x squared. Therefore the final answer is going to be this 3 times this 2. That is going to give us 6y squared, and then down we have got 5x squared. So this is going to be the answer for this question in simplest form. Okay, we can also look at this one. Simplify 1 minus y divided by y squared minus 1. Now for this question, y minus 1, you can see since the one with a squared, we've started with a y, right? So even the one on top, I'm going to start with a y. So if I take y the other side, this is a negative y. This one here is a positive 1. So that is negative y plus 1. And then down we have got y squared minus 1. So on top, I can factorize out a negative. So I'm going to have negative 1. Open brackets. What is going to remain here is only a y. And then this one will become negative 1 because it was positive. This one is the difference of two squares, meaning that is going to become y minus 1 and then y plus 1. So you can see that y minus 1 here will cancel with y minus 1 there. So what has remained on top is just a negative 1. Down what has remained is a y plus 1. So this is going to be the answer. Is this okay? Right. Let's consider this one as the last one. So again, since you can see there's a division here, we're going to change into multiplication. So we're going to have 99 m cubed n squared over 20 p squared q to the power 3 times the 40 goes on top, p squared q to the power 3 over 33 m to the power 4 n. So from here what you can see, p squared will cancel with p squared, q to the power 3 will cancel with q to the power 3. 1n here will cancel with 1n there, so we're going to remain with 1n. And then m to the power 3 will cancel with m to the power 4, so we're going to remain with 1m. And then 20 can go into 40, that is 2 times, right? 33 can go into 99. How many times? That is 3 times. So what we have remained with on top is the 3n. Down we have not remained with anything. And then the other side what we remained with on top is 2. Down we have remained with m. So meaning that the final answer is going to be 3n times 2. That is going to be 6n over m. This is going to be the answer.